What was that name of that electricity detective again?
I think it was Sherlock Holmes?
Yeah. That sounds right.
Yeah,
I think so.
yeah. What was that? Wait, are you little me?
I knew I should have bought a different dress.
Wait.
Why is mine a boy?
Listen.
What?
Listen.
Wait, flip the script here a second. Fill us in.
Both of us were randomly selected to participate on a government study of time dilation.
We were sent at different ages going different speeds.
Great. Physics already ruined normal life, and now this.
It's no mistake you two became friends.
This was all planned.
Now we're back.
You did just learn about this, right?
I guess, but then again...
Here's simple proof that this is possible.
Use the standard equation and just plug in numbers. I left when I was 6, and it only appeared to be 1.5 years. But to you, it was 10.
And I left when I was 4, which appeared to be 11 years to you.
So, what kind of everyday things did you guys miss when you were on your little space vacation?
Ice cream! Disney movies!
Great. Another two things AP physics is ruined for us.
You can't ruin Disney movies.
Well, as that's been proven, you kind of can.
Which thing?
Well, turns out Sleeping Beauty should have died, and Prince Philip couldn't have killed Maleficent with the degree that he was holding his sword. You know, I need a board to explain this.
Oh, we can just go to my house.
See, if you look at the dynamics and kinematics of the throw, it's really unreasonable to say that the sword would have hit her in the chest. If anything, it would have scraped her belly and given her a minor scar. The average velocity of the sword being thrown javelin style, as it was in the movie, is about 15 meters per second.
Since the average man at the time was about 6 feet tall, or 1.8 meters, we can use the shot of Philip to look at everything proportionally and find the actual height and distance in the scene, as well as get angles of projection to analyze the kinematics.
Philip is standing at an angle to the horizontal theta p, which is equal to 30 degrees. His sword, however, is projected at an angle theta s, and theta s is equal to 20 degrees. If you look at it proportionally, the distance between the heart of the dragon and the tip of Philip's sword is 4.5 meters. And since the dragon is so hunched over, even though it's actually very tall, the height to its heart is 2.7 meters. Since the tip of the sword is at the same height as the tip of Philip's head, we can use 1.8 sine theta is equal to y0 to find the height of the sword at the release. And since theta is equal to 30 and sine 30 is equal to 1/2, thank you, Mr. Italico, y0 is equal to 0.9 meters. So now we move on to the kinematics equations. Now, since this is thrown dagger style, we don't have to worry about rotation or any of that, and we can just use basic equations. First, we'll start with the x distance, because we know how far it needs to travel, we just need to know how much time it takes. So, using x equals x0 plus v0t plus 1/2 at squared. We can let x0 go to 0 because it starts out at the end, and there's no acceleration because there's no air resistance. Now, 4.5 is equal to the velocity, which we already said was 15 meters per second, but we have to compartmentalize it, so we have to use the cosine part. So it's cosine 20t. T is in fact equal to 4.5 over 15 cos 20, which is equal to 0.32 seconds. So So now we move to the y direction, for which I'm going to use the color blue. Use the exact same equation, but with y's. Y equals y0 plus v0t plus 1/2 at squared. Now since we have a y0 and acceleration, these cannot go to 0. Y in fact equals 0.9 plus 15 sine 20. It has to be sine because it's the opposite part of the velocity times the found time, 0.32, plus 1/2 negative 9.8, which represents g going in the opposite direction of the velocity, times 0.32 squared. Now if you computed all of this, you would find that y is equal to 2.04 meters, which is in fact far too short to hit Maleficent in her heart.
The dragon lady would have gotten scarred and angry, and Philip would have lost his sword, the kingdom would have fallen to the witch, and Aurora would have kept in an eternal slumber forever because her prince had failed to show up. Just like in every teenage girl's life. Ta-da! What?
Not only that, but remember when Mulan was being super awesome and killed Shang Yu and then slid down that rope with all the lanterns on it?
It's pretty sick.
Yeah?
Well, that wouldn't have worked either. For one, the rope was tiny. It was built to hold lanterns, for heaven's sake.
An average rope of that size would have been able to hold about 20 newtons of force. Assuming that Mulan was about 120 pounds, or 54.8 kilograms,
She was a peasant back then, and peasants weren't exactly well fed.
the force due to her weight alone would have been far too much.
There's no need to even compartmentalize or look at this in a more dynamic way. She's simply just too big for the rope to hold.
The rope Mulan was swinging on wouldn't be able to stand the tension caused by her weight, and would have snapped. She would have been sent plummeting to the ground, and you know what that means. Plus, there weren't enough balloons to even consider holding up Ellie and Carl's house.
Woody and Buzz wouldn't have been able to fly/fall with style.
And neither could Dumbo, realistically.
Don't even get me started on all of the things wrong with Mary Poppins.
Stop! Don't you get it? Disney movies aren't used to be analyzed.
You take them as they are and love them with all your heart.
Don't rip them to shreds after small mess-ups.
We can't stand you guys.
We're going home.
Where is home exactly?
Outer space.
Michelle? Oh my god, dude, did you just...
Wait, did you have a dream with time traveling little Mason?
And we started explaining Disney things.
Wait,
Mine was a guy, and I don't understand, and what was...
holy sh**!
What? Wait. Was JC there for you too?
Oh, Tosh. I'm always here.